Good afternoon, good evening, good morning. It's my great pleasure to introduce my colleague, friend, and host at KTH in Sweden now. Professor Sebastian Meyer is a full professor of healthcare logistics at KTH Institute of Technology, and he's also the vice dean of the Technology and Health School at KTH. He's also the head of the Department of Biomedical Engineering and Health Systems. He's the one who introduced and taught us the use of game-based policy design to the groups I was part of while I spent time in India. He was part of a large Bangalore transportation design project with Professor Rajagopalan of IIIT Bangalore and myself, funded by the Dutch Science Foundation and Shell Oil. He has been a PI of many cross-country European projects in transportation and health system. He is still building collaborations with groups in India. A person of many dimensions, he loves Indian tribal metal structure. He's also been a sound engineer for several concerts by European bands and singers. With that, I'll hand it over to you, Sebas.
Thank you very much, Sub. A pleasure to be able to, share some thoughts and some learnings over the past couple of years here in this forum. For those of you, it was Sub that through a connection at Delft, introduced me to the Indian context and made me travel to India over a period of 10 years, one to twice, sometimes 3 times a year, usually India South. So Bangalore, I've seen developing over the past 2 decades. Great to be here. I would like to share some slides, and it was working before we did this. So if I now do this, you should see the full screen. Does it work?
Yes.
Yeah.
Perfect. As Sub introduced, I have a lot of different hats. And what is common in all of those is that I try to deal with okay, how do we change systems? And I particularly try to work with those things that we don't know yet. And that leads me to a certain extent, okay, where are we? Where are we in society? And this is a fantastic picture that was made during COVID. To a certain extent, we're in the era of very large crises. And if we just did have COVID-19, currently we're seeing all kinds of forms of recession or at least financial instability. Climate change is obviously challenging the world. And then we have the biodiversity collapse. And with that, our food could be gone. Obviously, we're in crises and they follow each other. They are also interrelated. So in my corner of the world, I now work a lot with what we call health systems engineering. And there I see that this is an emerging discipline, traditionally between, let's say, physical systems and data systems that together form biomedical engineering. And biomedical engineering, trying to do devices, trying to do medical technology for hospitals, for home use, but they very rarely actually involve social systems. Much of these systems have been made for being able to measure a heart. And maybe there's a user, but biomedical engineering traditionally solved the physical and the data issues. Nowadays, if we actually talk about health, it's fantastic that I can monitor exactly all the blood values of a particular patient, and that we have these sensors that you can put on your arm for 2 weeks and you get a warning in your phone if your glucose levels are dropping. But actually the best predictor for success of certain medicines in almost all diseases is not whether the right diagnosis was made or whether we have a more advanced medicine. The best predictor is knowing whether people take their pills, which shows that while we can do a lot on the advanced side of science, if you ignore the social system side of things, you're not reaching your goals. So all of these systems actually work together. These are examples from our own department. We do things on heart pumps and um, tissue visualization, but we also see that large-scale systems, complex systems methods, and measurements on the individual actually combined need to span this, what we then call health systems engineer. With that being said, what I try to look at the world with an engineering systems perspective to be distinct from systems engineering. Engineering systems more as we look on systems with the glasses of the engineer. And what I dare observe is a shift from what I would like to call aspect systems to subsystems. A little bit of theory, sorry, we're in science. You have the complex adaptive systems literature, really looking towards emergent behavior because of dynamic relations, because of adaptive behavior of all the agents. And you have socio-technical systems theory. And for me, those two, socio-technical systems theory is a subset of complex adaptive systems theory, where socio-technical systems theory tries to optimize a system for a particular type of performance. And we try to describe the performance between agents and technical components and agents in terms of structured interactions, structured goals, cognitive mapping, standardization between systems, etc. Once we get to the complex adaptive systems level, where policy comes into play, for instance, and human relations, all of a sudden it's out of the window with your structures, and because other factors are coming into play that you can't just engineer at the social technical level. For those of you that are old enough, I believe all of us are, I believe I'm more or less the youngest, soft systems methodology, of course, from the 1970s was, in my eyes, the previous wave of this. And I now see that we can have a new wave of this type of science, given the data-rich environments that we're in. Which means that if we talk about complexity, that we need to think about two types of complexity. On one side, the technical physical one, and on the other side, the socio-political complexity. And in socio-political complexity, for instance, one of the things that we have is accepted solutions. That doesn't mean that they're true or that they're the best or that they're even rational, but we can all accept, for instance, to stay home and to wash our hands. And but in those same dynamics, you can get all kinds of virus skeptics, disputed knowledge. Well, this was something that I always had to explain before the pandemic, but since the pandemic, everyone understands how this plays out, even at a global level. I use the word system constantly. And when I think of systems, the big question becomes, how do we divide them into parts that are actually manageable? If we look at this meal, how would you describe this meal? Well, we can describe it, if you're Italian, very often as a main course, a side dish, and a sauce. Might be guacamole or whatever it is, green sauce. If you're a food scientist, you would describe these in proteins, carbohydrates, and fats. If you are dealing with heat, you would describe this as cold or food safety as cold foods and warm foods. The way you describe this really shapes how you can actually do something. And if you get to the professional world, of course, we need to be effective. We have experts working in their own domain. We have all kinds of professional evaluation cycles. And for instance, in the health world, everything needs to be evidence-based. And for that, we have randomized control trials as a sort of golden standard. But at the same time, we know that doctors are totally swamped in information. There's what Schwartz called the analysis paralysis. There's so much information that it's very difficult to actually substantiate that whatever we do in the health sector is evidence-based. Very difficult to track every decision back to certain evidence. It's more a professional training, and maybe then whom to trust is more important in this. And well, this illustration on the right, that a good doctor is somebody who you can trust, whose advice you want to follow, and also tells you a little bit about what you actually want to hear, because otherwise it's difficult. All of this is similar to, okay, we're in a world that is more and more complex. It's difficult to make rational decisions. And all of a sudden we get this focus on data. You can't do a research proposal these days without mentioning the word AI. I love this picture. That's it was Zaman et al. 2016. I guess you know it, where they called this the 5 V's of big data, and they actually have 6. It's a beautiful picture. But this influenced a lot of public policy decisions regarding, okay, now we need to look at more data because we have large volumes, we have a large variety. It's coming in with a larger velocity. How do we deal with this? But what I see is that actually the move towards looking at real world data is very, very complex. This is a picture from my colleague, Anam Darwish, working in our group, who tries to compare, for instance, what is known from randomized clinical trials with what is known about the population. And what you see there is that actually all of our evidence, or everything for which we build models that we accept as truth, are only evidence for very select subsets of reality. And then you start looking at the real world data, RWD, and that's really a Pandora's box that you're opening. I do a lot personally with health data, and it's not just clinical data, data generated at the hospital that is increasing in volume. Of course, there's a lot more molecular profiling and a lot more imaging going on, and that data is also getting more available. But what we also see is that, I don't know how many of you have a smartwatch that measures your blood pressure and heart rate continuously. But the amount of data generated, both at the individual level and at the societal level, that is related to health is also exploding. So this is an interesting combination where very often if we say health, we think of the hospital clinical setting generating more data, but it's also the patient themselves, and it's also the society around it. And there's a Swedish researcher who makes the strong case for actual patient involvement and patient source data. She has Parkinson's disease, rather progressive. Unfortunately, she's a very good researcher. And she makes this case that actually healthcare only has 2% of the data about her disease, and that 98% of the data is something that she herself has or can collect from the environment. So if you then look at like, okay, evidence-based is actually maybe not so evidence-based as we like to believe it is. If we see that data is then going to weigh our way out, then the question becomes like, okay, how do we capture this reality? What is that evidence-based? And what I observe is that while everyone speaks about evidence-based and the need to steer based upon that, there's a filtering process going on. And that is, first you need to get the data from reality. There's a certain filtering there, because certain data is very difficult to get, whereas more easily accessible data very often gets most attention. You need to have models about the meaning of this data. Who makes those models? There's filtering. Then, of course, you need to do computation, which again reduces the richness of what we know about reality. Information systems, you need to have tools for giving meaning to the processed data. And of course, then a pathway to convert meaning to actual decisions. And if you think about this critically, all these 6 steps are reductionist steps because no method is perfect and can actually deal with all the richness that is there in the data. So either we are going to rely on a mean, we reduce the outliers, or we just ignore everything, all the aspects for which we can't collect data, and we just do it with what we have. And this is problematic because it says that we're working more data-driven, but it is very often uncritical to what data-driven actually means in terms of capturing reality. At the same time, this is something from Sweden, but it's very true for a lot. Sorry, water. Here in where I live, we simply cannot afford the aging population. We're a very wealthy country, but we cannot afford the amount of elderly that are coming in or that are aging right now. That's simply the baby boom. And in the bottom picture there, you see the demand efterfrågan at the top turquoise one is the demand for healthcare staff, particularly nurses and social work, social nursing. And the bottom one is the prognosis of personnel available to take care of our elderly. And on the right-hand side, you see something that we also observe in almost all societies, and that is that the mental health is deteriorating. And not just the number of in crisis and struggling people who need health care, but it's also a reduction with that left shift of the mean, a reduction of the people that feel well and therefore can actually support society and do the positive things. So these are 2 crises that are coming towards us and for which we're very ill equipped at the moment. Something that we see everywhere is then the logic of trying to flip this pyramid, as we often call it in healthcare. Currently, tertiary care, very advanced healthcare is taking most of the budget, and very little actually is spent on preventative and public healthcare. And the desired direction, this is actually a paper from India. I often use it here in the Swedish context to show that we're not alone. Even a big country has the same issues. But there's this goal that very simply, we do more work on the preventative and the primary care levels to make sure that the very expensive care is only there for those who really need it. And to be honest, there's a lot of stuff that can be prevented, and there's a lot of stuff that can be dealt with in time to avoid that things get worse. So in our group, we do a lot of studying healthcare processes, quite some process mining. Which processes can we actually get from this data? We do some prognostic analysis based upon data that we get from different cohorts, different hospitals, and all of this is what we would call real-world data. And in these studies, what we very clearly see is that a lot of the knowledge actually isn't captured in formal data. If you speak about elderly care, what is the character of a patient? What do we know about a patient's history? Much of that is more of a professional attitude between nurses and doctors than it is electronic health records type of data. We also see that actually agency, who has the mandate, influences what data is there and how it is captured. And you really need to be aware of where the incentives are to be able to understand the data. And that means that even if you think data standardization could really help to exchange data, you still need to know the context of the data at the local level to be able to make any meaning out of it. We've received fantastic amounts of data where we can't do anything about it just because we don't know what was the context in that particular clinic. And trying to analyze that data just with regular methods would lead to completely wrong, leads me to the current understanding that if we try to do systems change and we try to involve modern ways of working data-driven, particularly AI, it is meaningless if we don't represent the stakeholders. Surprise, surprise. In design theory, this is of course rule number one. It's not that we don't know this, it is just that it is largely ignored in the more data-driven and semi-objective rationale currently in the public sector and systems change in general. So here are some examples. I'll just talk about the bottom one. Here you see the number of social reports per age and calls over a certain time period. This is a data set that we got from a municipality, and a social report is filed by, it can be filed by many different stakeholders if there are concerns about the social circumstances of a person. And what you see here is that actually the number is high, 15, 16 a bit lower, 17 it goes up a lot. And then 2 years it's relatively mild, and then it drops down dramatically. Do you believe that 17-year-olds in Sweden have a lot more problems than 16-year-olds? I guess you don't.
No.
No, exactly. So the reason that we actually see this huge drop is because the Swedish school system forces you to switch schools at the age of 16, halfway the age of 16. So in the last year, because very little can be done, there are very few reports. And then they come in at what is called gymnasium at the age of 17. And all of a sudden, there's a lot more reporting because people see kids with fresh eyes. And it's almost by a third. And all of that is because of the structure of society, the structure of the school system. It has nothing to do with the thing that we actually try to measure. And also the drop from 19 to 20. Do you believe that 20-year-olds are so much better off than 19-year-olds? No, they aren't. At least not if you look at clinical records, for instance. The entire reason for that is that they go out of the structured school system and go to universities at the age of 19 or go to work. And there's no social structure for doing that reporting. Just showing a very simple example, very logical if you think about it, but where you need to be super, super precise about what is it actually that we're looking at and how is this data generated. The problem is that when you go towards AI and multi-factor, large, complex models, we tend to throw in a lot of different data because the model will learn. Yes, but it will also learn these types of things. And this is the primary source of your hallucinations for the models later on, if you would continue just doing this. There's another example. I'll just tell you about the left side. In Sweden, there's a law that says that if you have a particular diagnosis, that you need to get the first visit to a specialist in 30 days. And here you see a regular chart. You see that actually for most on the left side, you see the different diagnoses. They're in Swedish, but there are things like alcohol and drugs, and there are all kinds of things like psychosis, fear, manic depression, hyperactivity, etc. And what you see is that on average, the healthcare system is doing rather well in giving you an appointment within 30 days. That's the red dotted line. And then you could start to focus on like, okay, there's a couple of diseases where it's or diagnosis where it's a little bit delayed. Should we do something about capacity there? But what is ignored in all of these plots is the dots. And in Sweden, what we actually know is that the child psychiatric care has a very bad reputation. There are all kinds of cases in the newspapers of youth not getting proper treatment. You can't explain that if you focus on the mean and the standard deviation on the left side of this picture. But if you start looking at the outliers, there's actually days between the time, so the time of the referral and the first examination. And there are people that have been waiting for 500 days. That's 1.5 years. If you start looking into those dots and you actually separate those from the data set and start mining into what happens to these kids, why is it that they get treated or their first examination so late, you actually dive into a gigantic trauma and drama of patients that are not at the right healthcare location, that do not feel well, that have very large difficulties, much larger than just getting healthcare. And those are the things that actually pressure the healthcare system, because the routine people that just can be treated, those are not the ones that actually pressure the healthcare system. It's the ones that are dramatic, that are difficult. So here again, if you focus on the mean and average and standard deviation, it doesn't really help you. If you focus on also the data outliers, which very often data-driven methods ignore, then you get a lot more knowledge about what actually needs to change in a system. In our work, what we do is that we call this methodological layering. At the bottom, data mining, AI, to get this rearview mirror, knowing how the system behaves currently. And then to add simulations to be able to do future studies, because only if you have causality and you can build that into a model, it is plausible to do any reasoning towards the future. Then still you don't take into account the more advanced human reasoning. And that is where we add games as the top layer to test ideas, but also simply to try to understand the actor complexity that exists around many of these things. I'll skip this slide because it's getting a little bit over time. But if you then work with qualitative and quantitative data sources, you're able to create these simulations and games and AI in a boundary object type of way where it's possible to interact with them. We've shown in multiple projects that you can then create a collaboration space to actually get a theory of change that is much better substantiated than just running AI models or data-driven methods, because you capture a couple of things that otherwise are almost impossible to capture. One example, we've been doing work on small cell lung cancer studies. This PhD student, Luca Marzano, he simply got data from the real world, but also involved the stakeholders. And in the process of creating the data models, doing the machine learning and AI, we designed the role of the clinical domain experts. And this leads to a combination of, from left to right, so to say, an analytical science, a data-driven approach, where we really learn from the numbers. But what we also notice is that by doing this in interaction with the clinical domain, you actually also have a translational science approach at the same time. This will be topics of further studies for us to like, how do you design the agency in these types of AI types of models? Of course, you can do this multiple times after another. Well, then you get to almost design as temporary closures in a change process. Some forthcoming work. We worked on trying to position game science because of the simulations and AI world. It's the games actually in this methodological layering that are the most ill understood. So we worked a bit on the philosophical underpinnings, particularly the ontological and epistemological perspectives. What can we actually learn from these? Skip this. So summarizing, real-world problems require, in my view, real-world data analysis. And to do that, you need to be able to deal with the professional reductionism. And this professional reductionism is almost standardized these days because of the way we think about data and think about data-driven methods. We try to add gaming to help capturing those knowledge structures that are different or that say something about data and models. And for that, I don't believe anymore if you want to do a scientific approach to systems change in following one method, you need to do this layering of methods. But it's also essential that you don't abstract away everything to be able to play with something highly abstracted. It's very important that you do not throw away things. And well, with that, I hope that with time, game science could be as rigorous as data science or natural science. Thank you.
Thank you very much, Sebas. I know you wanted to do something on transportation also. You actually have quite a bit of time left, almost 20 minutes left. So if you do feel like adding something, I will be more than happy to let you do that, because I think that will also add to the point you're trying to make, that it's not just health systems, it's engineering systems at large. It's up to you. If you don't
Yeah.
want, we can start with questions. I would be delighted if you do a little bit of that too, or at least talk about it. Yeah.
Yes, you know too well what I've been working on.
Oh, I've been with you for a very long time.
Yes, indeed. I'm looking up some slides for that, but I actually thought that you instructed me to do 30 minutes and then
Yeah.
discussion.
Yeah. Use some more and then 10
Yeah.
minutes or 15 minutes, and we still have about 15 minutes of questioning. Yeah.
Okie doke. Here I have you see my screen now?
Yeah.
It's not in, yeah, good. A lot of work before I moved into the healthcare domain was in public transport systems. And I worked in the Netherlands. I live in Sweden now, but I'm Dutch. In the Netherlands, I worked a lot for ProRail, the Dutch Railway Administration. They are not a train operator, but they take care of traffic control. They take care of maintenance of tracks and simply provide the infrastructure for companies to drive their trains on. And the largest company is also the former state monopoly. It's called the National Railways, NS in Dutch. They basically operate on 90% of the lines, and then 10% of the lines is smaller operators. And the Netherlands, as you might know, is a very densely populated country. It's also very small. So railways are really the way to go. And that was also something that the Dutch parliament and government recognized. And the goal was to get to 100% extra trains and already 50% in 2012 at the regional level on almost the same network. Because they calculated what would it cost to be able to double the trains with the current paradigm, and that would have cost us upwards to 60 billion euros. And that calculation was done 20 years ago. So inflation over that. And they only had about 10% of that budget available. So the question then becomes like, how do we test how far we can push the system and where we need to make specific changes, because we can't do this the old-fashioned just double the infrastructure and go type of way. What we then did was designing these games, gaming simulations, I would say, with railway operators, very many different types of operators. And usually these simulations were based upon a computer simulation, on top of which we added the human decision maker. Of course, now those of you that have programmed simulation models will immediately ask, like, how do you get the connection between the simulation model and reality? Well, that has been one of the big challenges. And after I left, and well, I was still a bit involved, but after about 12 years of work, they are now at the level where they have human in the loop simulations of all kinds of functions for the railways built into an existing lab in the same location as their main national traffic control center. So from what you will see, a very analog approach and trying to bridge between games and simulations, all of this has now, through IT development, etc., been incorporated into something that is regularly doable and used on a daily basis. What we also noticed here is this talking with the operations doesn't help, because in such a classical operational system, it is actually, there's so much knowledge with the operators that is not represented in any of the simulation models, and it's very hard for them to actually explain to the engineers and the designers that you need to have them doing something to be able to make their mental model explicit. So what does this look like? Now my movie doesn't want to run.
We used all kinds of
you're here.
Yes, good. We used all kinds of human in the loop simulations, getting people to work around a joint analog simulation very often. So they were pushing sponges or other models, and we used very different models. We experimented with very different models of what does it mean to play with a model of a train. What we learned here was also that the way you actually make people interact with what we call a train, is it a iconic depiction? Is it something that you would recognize as a train of a particular type, or is it very clearly a toy that has a meaning for the way we do interactions with the simulation model and the way we trigger people to expose their mental models? So what we found, and this connects to, I guess, Sub has been talking about, for instance, the PSI model, but what we found was that a change in the product space, we were adding more trains to the railway product, led to necessary changes in the social space. For instance, if disruptions occurred, we needed to change the number of perspectives involved in actually solving solutions. Otherwise, the entire network would come to a standstill. And that actually has happened. So we've been involved in parliamentary investigations into why certain incidents happened with this methodology. But involving different roles from different railway operators, for instance, and control centers also led to requirements for changes in the institutional space. Who are actually involved? Who has the mandate under certain circumstances? And this is now all embodied in a function which is called the Operational Control Center, OCCR. And that model was built and designed with this gaming methodology to try to figure out, like, okay, how should we do this once we add so many more trains to the railway network? And of course, gaming was never the only method. This was a part of data analysis, and we're now talking about 15 years ago. AI wasn't that much on the radar, but simulations, very advanced simulations, we had computers running all of the time, and mainframes and whatever, trying to figure out the most with the models we had. But doing this in a gamified way actually exposed limitations of the formalized knowledge in the organization, which was very, very meaningful for the way we could work in reality.
Thank you very much. I think the two things from the two lectures that are connected is that not only do you have to identify the problem correctly and also the stakeholders correctly and use the right kind of data, uh, as only using averages and means and even using RCT trials, which are population data rather than personal data, does not provide you with the kind of insights into solving these engineering systems problems in both cases. And in all of them, as you said in the first one and in the second one, it's not just the problem. Sorry, I didn't have my video on. It's not just the problem, it is also who is brought into the space in order to solve the problem, in order to address both the formulation and the solution of the problem, and how it also leads to the changes in the institutional structures that are required to accommodate these changes, both from a social sense and the problem being addressed sense. I just wanted to summarize that, given that the two of us have been working on these issues for a while, and also that it is imperative that we look at these engineering system problems in their totality. So with that, I'll let others ask the questions, because I know what questions I will ask and you know them, so I'll let others ask the questions.
Sab, may I?
Sure.
I would like to first mention that Sarabjit Singh is here with us today, and he is former very senior engineer from Indian Railways, and I would love to have his reactions to the transportation, especially to the transportation part of the presentation, and in the simulation of what you can learn. My own thought was that major problems arise both in health and transportation when events of low frequency arise. And in case of transportation, natural accident, natural events, weather-related events, and so on, how the regular regular operations of a transportation system cannot be based on the assumption of those infrequent natural events. And yet those infrequent natural events, when they occur, can throw everything, carefully designed systems, out of filter and seriously disrupt everything. So in the gaming approach, how are these low frequency disruptions to be handled? That is one thought I had, a question I had. I'm not sure what would be the answer, but thank you. Thank you for your great talk.
Thank you for the question. It's a very good question, because it drives us back to a very fundamental understanding of what reality is. Is reality the ongoing continuum, or is it actually shaped more by the disruptions? And even historically, society is very often shaped by the disruptions more than the continuum. Um, given that we are getting into the era of more and heavier interrelated crisis, you could also argue, and complexity theory people do this, that the number of crises and the incidence of this will get higher and is also no longer, it shouldn't be a surprise. Very often they come as a surprise because they're difficult to foresee exactly when it will happen. But that something will happen should not no longer come as a surprise, which then leads to a deep discussion I've had with the ministry and the leadership at the Dutch railways. Are you designing for capacity or are you designing for robustness? And those two are not entirely the same.
Yes.
And there, of course, you get the commercial, the Dutch system is based on a half market solution of independent operators who decide on their own train traffic schedules as long as it fits on the tracks. The current country where I live, Sweden, has gone even further. Here, the government has no control over what lines will be driven on the long distance railways, and they have to say yes as long as they can accommodate, which leads to very vulnerable timetables. And the smallest disruption throws the entire country, and Sweden is a long country, as you may know. Um, the smallest disruption disrupts the entire country. Then you can question what is actually the public good that we produce here, because the economists usually only include the value of people being able to go to their work, the minutes saved by more trains. And I believe we should get better into also understanding the value or the avoidable cost of disruptions. But that is a knowledge that is very difficult to operationalize, and therefore you need to talk to these very operational people. Often do not speak English, at least not in the Netherlands or Sweden. And if I would have said like, hey, I'm a professor, and would have sat next to them, they would have ignored me completely. But I always went undercover in a t-shirt and sat next to them and just spoke about the weather, etc. And so who do we invite to the table to design the future systems is totally related to the way we perceive the balance between design for capacity or design for robustness, where we need this type of knowledge integrated. And that's almost an ideological choice that you can make. It's also to a certain extent political.
If I may just add a health-related example to this. A couple of years ago, with the height of COVID pandemic, there was a severe shortage of oxygen respirators and oxygen supply in hospitals in many parts of the world, including India. And this has not been anticipated. The level of oxygen demand will be so high. And since the pandemic, that particular pandemic has subsided, most of those machinery, I believe, I'm told, are lying not only idle, many of them have become are not really in order anymore, and they'll probably be discarded before the next pandemic comes along. And the question of maintaining the supply of such equipment, training, personnel for meeting low frequency demands? It's a difficult question I'm sure in healthcare as it is in transportation. I just wanted to add an example. I'd love to hear if Sarabjit has anything he wants to add to or ask any his those questions.
Okay. Thank you, Shyam, now that you put me to it. So, by the way, Shyam and me go down very far because we studied together engineering. And he was also in the railways before he became a professor. So, and so I've been on the Indian Railways, and what you talk of, I'm going to talk from the practical side when you run the trains, because you're talking of modeling and you're talking of from the academic side. And I think what you've talked has made me think also of some of the problems which we actually face in the field. And this business of increasing capacity and not thinking of robustness, and the political class not being able to understand that is actually very correct. At least in India, we have that problem. Now, I'll specifically talk of accidents, because you increase capacities and to avoid accidents and to make sure that there is enough, because Indian Railways runs about 12,000 trains every day, transporting a few million passengers. And so it's a very big, large operation. And so there's constant push politically in order to add more trains and more capacity. But it does, and this is a new thing which I've learned from you, that it would change the social system. I think nobody has actually had a look at that. And it seems to fit it in a certain way that if you add more trains and you try to ensure that they are safe, what really results is that the frequency of accidents seem to remain the same, even though the trains are more. So the social system is working in a certain way that it tends to create safety issues. The way it works, because there are multiple pressures on the person on the field to fulfill multiple objectives. So the way they seem to fulfill them is to balance the safety issues and operational issues and lead to about the same amount of accidents, irrespective of the number of trains. Now, I don't think this has been recognized. So my question basically is, how do you bring this issue of robustness and change in the social system come into the decision making of the Indian Railways and also understanding of the political class?
Thank you. First of all, it's almost amusing to hear how similar these problems are, regardless of whether you live in a country with snow and cold or whether you live in a country with highly densely populated. And I know you have snow in the Himalayas, but major parts are hot, at least for me. I hope that if we can continue the academic discussion regarding these types of methods in, well, a little bit along the way that I try to present, and have a senior interaction with engineers in large-scale systems, that we can actually move the needle a little bit on this paradigm. Because in the end, if we don't tell them that they're wrong, they will never learn. So it's also something that I believe is up to us, as maybe the happy few or the ones who refuse to give up, to actually try to push this perspective forward. Because if we don't, we know that a lot of resources just will be gone and lost forever. I'm absolutely sure that the world will get into even more crises before recognizing this widely. But let's hope that we can be a little bit ahead of that curve by telling.
Sorry, I didn't get the
David?
last bit. I didn't get the last bit.
Can you
I-
repeat the last part? Yeah.
Absolutely. My conclusion was that I hope that we can be a little bit ahead of the curve of crises that will force us to this understanding by telling the right stakeholders together that we need to move this perspective. Otherwise, we are missing what is essential.
Yeah, one observation is like, for example, if we are trying to solve the information explosion problem by building more models or enabling collaboration or discussion around the using the games and other things, it may still be stuck in the paradigm of dealing with that information explosion, right? But what do you think about the possibility where the games are used to actually trigger discussions on the paradoxes in the current socio-material structure, which can lead to breakup or changing the socio-material structure, which is generating that information in the first place?
That is a very interesting question. What is important for you to know is that you can see it here at the back. I'm a sound engineer by background. And I've been touring for 15 years, 20 years, all over the world. And what that world taught me compared to the academic world is that tonight at 8 o'clock, you will have 15,000 people here. Either you solve the problem or you're gonna explain to all of them individually that you fucked up, to be very explicit. What I try to say with that is we need to be sufficiently concrete in what we can do, because a lot of the things that need to be delivered are here right now. So while I agree with that, many of the systems that actually generate this data or actually generate the problems may need some fundamental discussion themselves. That is a change trajectory that is maybe in the span of 20 to 30 years, rather than something that can be done in the next 3 to 5 years. And while that may be desirable, my mission, as I perceive it, is more to get the people from looking 2 weeks ahead to maybe 2 years ahead. And 2 decades might be a leap too far in this, which doesn't mean that I don't agree with you to a certain extent. But on the other hand, you also need to be practical in it's 8 o'clock tonight and there are 15,000 people coming.
Yeah. So, for example, I think there was also this case of where you have a certain number of signals and in the traffic signals, and you have a certain volume of traffic. And when you have more signals added to that process, it becomes more complicated at some stage. But one of the solutions people have also looked at is why not get rid of the signals itself and see how through micro interactions the problem can be solved. It is still within the time frame which you are talking about, but looking at a kind of a physical rearrangement which can lead to dissolving that problem, right?
Yeah.
So is that
Uh,
something which can be explored in a game? That's my...
Yes. So here you get to like system changes that are of a larger level. Yes, you can do this, but what we also found is that the validity of the sessions that you do with that is very difficult to keep, because you take people again to think about so long in the future that it's almost impossible for them to imagine what the world will look like. So for people to be engaged in a meaningful way in these gaming sessions, they need to be able to understand how concretely that future will look like and what their role is. So the game design becomes very, very crucial to get right. Whereas things that are a little bit closer to now or to the current system are more easily gameable in a valid way.
Thank you.
If I may just make a remark, given that he's my games teacher, the game itself is a means to open up all the different possibility. That's why you have to be careful in designing the game. Thinking about whether you are designing a game for short-term solutions or making them look at the long-term solutions. So you can get waste management games which will allow you to explore the complexity of the problem, both at a micro interaction level, as well as what are the macro issues that impinge on the micro interactions level. So this is a dance between the two. And the way you design games is to make sure that you can really orchestrate this dance and choreograph this dance to get as much information about what you want to know and where you want to proceed. Reasonable summary, Sebas?
Yeah, no, definitely. Yes.
Well, thank you very much for a lovely lecture. And I think a very timely and important lecture from the point of view of this mad AI race, where we are not thinking about what is that we want to do with it, or what is that we are getting from it, what is the data, and how do we look for the right data and the right way to look at these problems, at least if not the right way, an open way to look at these problems so that we can deal with them in order to deal with more robust societies rather than purely chasing the notion of efficiency. And with that, thank you very much. And I'm sure everybody enjoyed the lecture.
Thank you.
Thank you.
Thank you, Sebastian.
Thank you.
Yeah.
Thank you, everyone.
Sarabjit,
Thank
can you
you.
stay for a moment?